For section 2.6, I'll be starting off with question number 5. And for question number 5, I need to factor each binomial. So when we're dealing with a binomial, we have two terms. And for section 2.6, we're pretty much learning how to factor using something called the difference of squares technique. So you have two terms and you have a minus sign in the middle. And that's a very good indicator that you can factor this by creating two brackets. And then you have a plus and a minus sign in the middle. And then after that, you're just taking the square root of each term. So the square root of x squared is x, and the square root of 1 is 1. So x plus 1 and x minus 1, and that's it. For letter B, once again, you have two terms, and you have a minus sign in the middle. So this is a good indicator that you're factoring using a difference of squares. So you have a plus sign in the you have a plus and a minus sign in the middle, and after that, you're taking the square root of each term. The square root of 4x squared is 2x. The square root of 1 is 1. So you have 2x plus 1 and 2x minus 1. So some of these factoring questions are a little bit easier as long as you can recognize that this technique works when you have two terms and a minus sign in the middle. All right, so let's go ahead and have two brackets, plus sign and a minus sign. And after that, you're taking the square root of each term. So the square root of y squared is y. The square root of 25 is 5. So y plus 5 and y minus 5. For letter D, once again, we have two terms, and we have a minus sign in the middle, so we can set up two brackets with a plus and a minus sign. The square root of 25y squared is 5y, and the square root of 9 is 3, so 5y plus 3 and 5y minus 3. Okay, for letter E, once again, we have two terms, and we have a minus sign in the middle, so let's go ahead and set up two brackets, plus sign, minus sign. Square root of 4 is 2. Square root of 9z squared is 3z. So 2 plus 3z and 2 minus 3z. All right, letter F, two terms and there's a minus sign in the middle. So this is a difference of squares type of factoring problem again. The square root of 16 is 4. And the square root of 25z to the power 4 is 5z squared. All right, so hopefully these problems aren't too bad with some of these entry-level problems here. Once again, we have two terms and a minus sign in the middle, so you can go ahead and set up two brackets. There's a plus sign and a minus sign in the middle, and then you're just taking the square root of each term, so 4x and 3y. All right, letter H, another problem where we just need to recognize that this is a difference of squares type of factoring problem. Then after that, you're just taking the square root of each term. So this is 5x to the 2 and 9y to the power of 3. So 5x squared and 9y to the power of 3. Okay, for letter I, before we start using the difference of squares factoring technique, you should recognize that we can factor out a common factor. So the greatest common factor here is a 4. So let's go ahead and pull the 4 out first. If I pull it to 4, we're pretty much dividing each term by 4, so I get 4x squared y to the power 8 and minus 1. And then after that, you should recognize that we can factor the inside, which is a binomial with a minus sign in the middle, using a difference of squares. So using the difference of squares technique, I need a plus sign and a minus sign. And then after that, you're just taking the square root of each term. So the square root of 4x squared y to the power 8 is 2x y to the 4, and the square root of 1 is just 1. So 2x y to the 4 minus 1 and 2x y to the 4 plus 1 all times by 4. Okay, let's move on to letter J. And for letter J, just like the previous question, I have a 20 and a 5. So the greatest you need to start off this problem by factoring out the greatest common factor, which is 5. So you can divide both terms here by 5, and you get 4x squared minus y squared. And then after that, if you take a look at the inside here, you can factor that using a difference of squares. So two brackets, plus sign, minus sign, and after that you're taking the square root of each term, so 2x plus y and 2x minus y. Okay, let's move on to letter K. Once again, this is a difference of squares because you have two terms and a minus sign in the middle. So let's start with two brackets, a plus sign and a minus sign, and you're taking the square root of each term. So the square root of x to the 4 is x squared plus 1 and x squared minus 1. All All right, one more thing that you need to do with this problem is you need to recognize that over here we have another difference of squares because you have two terms and a minus sign in the middle. The key thing is you need to have a minus sign in the middle to continue factoring. So you can set up another two sets of brackets and plus sign and minus sign, and just take the square root of these inside terms. So the square root of x squared is x, the square root of 1 is 1, so x plus 1 and x minus 1. Letter L, you can't factor. Although it is a binomial, you can only factor if there's a minus sign in the middle there. So that one you cannot factor. And for letter M, this is still a binomial because here are your two terms and you have a minus sign in the middle. So you can factor this one by setting up two sets of brackets, a plus sign and a minus sign. And then after that, you're just taking the square root of each term. So the square root of x plus 1 all squared is just x plus 1, and the square root of y squared is just y. So this will be x plus 1, and this will be minus y. And that's it for that one there. Letter N, there's two terms, and there's also a minus sign in the middle, so you can factor this using a difference of squares. And there's a plus sign and a minus sign in the middle, and after that you just take the square root of both terms. So the square root of 4 is 2, and the square root of x plus 2 all squared is just x plus 2 and x plus 2. Now, although this is correct, you can still continue to simplify this. So 2 plus 2 is going to be 4, so this is going to be 4 plus x. And over here, you have a minus sign, so if this minus sign distributes into the brackets here, you get negative x minus 2, and you still have that 2 there, and you'll notice that these 2's cancel off, giving you just a negative x there. All right, so that's the final answer there, 4 plus x times negative x. And we just have a few more to kind of finish off this particular section here. So two terms and a minus sign in the middle. So this is a difference of squares factoring problem, plus sign and a minus sign. And if you take the square root of the last term here, that's going to be a 5 and a 5. And over here you have x to the 2n. So 2n is the same thing as n plus n. So you need a x to the n here and an x to the n over there, and that should do it. And for letter P, once again, we have two terms and a minus sign in the middle, so a plus and a minus sign there. The square root of 9 is 3, the square root of 9 is 3, so I need 3's at the back end there. And if I take a look at the 6n, 6n is the same thing as 3n plus 3n, so this will be x to the 3n and x to the 3n. Okay, so that concludes all the problems from question number 5. Let's go ahead and move on to question number 7 now. All right, so for question number 7, I need to factor each perfect square trinomial completely. Okay, so we have a trinomial here, and basically for these ones, since we don't have a leading coefficient, our leading coefficient is just 1, I recommend that you find two numbers that multiply to 25, and those two numbers need to add to 10. So the two numbers that multiply to 25 are 5 and 5 plus 5 gives you 10, so you can write this as x plus 5 times x plus 5. And since both of these binomials are the same, you can rewrite this as x plus 5 all to the power of 2. Okay, let's move on to letter B. We need two numbers that multiply to 16, and those two numbers need to add to 8. So I'm thinking 4 times 4, and 4 plus 4 is 8, so this will be x plus 4 and x plus 4. And since both of those terms are the same, you can write this as x plus 4 all to the power of 2. Okay, let's move on to letter C now. I need two numbers that multiply to 36 and combine to negative 12, so that's going to be negative 6 and negative 6. So this will be y minus 6 and y minus 6. And this is going to be y minus 6 all to the power of 2. All right, letter D, I need two numbers that multiply to 9, and those two numbers need to combine to negative 6. So I'm thinking of negative 3 and negative 3. So two sets of brackets. I have a y to the power 4, so I should have a y to the power 2, half of 4, and y to the power 2 there. And this will be minus 3 and minus 3. And just like all the other previous problems, this can all be raised to the power of 2. All right, for letter E, you have to do one step at the beginning, which is factoring out the greatest common factor, which is 2. So if I factor out the 2, I get z squared minus 14z. And what is half of 98? Well, half of 98 is 49. And then ask yourself, how can I factor that inside trinomial? Well, I need two numbers that multiply to 49 and add to 14. So I'm thinking of 7 and 7. So since it's a minus 14, I need a minus 7 and a minus 7 there. So this will be z minus 7 times z minus 7. And if you want to rewrite this as 2 times z minus 7 all to the power 2, that's also correct. For letter F, I have a 3 here, a 30, and a 75. So you need to recognize that you need to pull out the 3 right away. And if I do that, well, mathematically, you're just dividing every single term by a 3. So it'll be z squared minus 10z, and 75 divided by 3 is going to be 25. After that, take a look at that inside trinomial, and I need two numbers that multiply to 25 and combine to negative 10, so negative 5 and negative 5. So 3 bracket z minus 5 and z minus 5, which is 3 times z minus 5 all to the power 2. All right, let's move on to letter G. X cubed, x squared, and an x. So the maximum number of x's that I can remove is 1. So x is the greatest common factor. And if I factor out an x from every single term, I get x squared minus 16x plus 64. And you know, we need to continue to factor that trinomial there, and I know it's going to be x minus 8 and x minus 8. So my final answer is x times x minus 8 all to the power 2. All right, let's do 2 more problems, and then we'll move on to some of the visual factoring problems next. Okay, for letter H, you should recognize that there's a leading coefficient of 9, and then there's a 24 and a 16. So I can't really factor anything out. So this is this is one of those smiley face factoring problems. So I need two numbers that multiply to 9. I'm thinking of 3 and 3. And I need two numbers that multiply to 16. But since this middle term here is negative, both of these numbers should be negative over here. So negative 4 and negative 4. Now if I use the smiley face technique here, I get negative 12 and I get negative 12 there. And negative 12 and negative 12 gives me negative 24. All right, so that works great. So going back to my green marker now, I have a 3 and a 3. So this will be 3x and a 3x. And this first 3 combines with the negative 4, so this will be negative 4y and negative 4y. And since those since the binomials are the same, you can rewrite this as 3x minus 4 all to the power 2. Okay, let's do a letter J to kind of finish up the questions from problem number 7. And for letter J, it's very similar to the problem that we just did. You just need to factor out the minus sign to get started. So if I factor out the minus sign, I have positive 9x squared, positive 24xy, and positive 16y squared. And this question is very similar to the previous problem as I mentioned. So the two numbers that multiply to 9 are 3 and 3, and the two numbers that multiply to 16. Now since I have a positive sign here, this is going to be positive 4 and positive 4. So 3 times 4 is 12, and 3 times 4 is 12, giving you the 24 that we need. The 24 that we need. So a minus sign, and I have a 3x and a 3x. And if I follow the 3, I mean that multiplies with the 4, so so the plus 4's go there, and I just need a y there, and an x there, and an x there, and that should do it. So very similar to the previous problem. The only thing that's really different is that this sign here is a positive this time, but it's very similar to the problem that we just did. Okay, I think the last few problems that I would like to try for this homework video guide are the questions from Part 8, where I need to write the area of the shader regions in factored form. Okay, so the shader region is pretty much this yellow region right there. So hopefully the shader region is a little bit more clear in your workbooks. And in order to find the area of the shader region for 8a, I need to find the area of the circle and I need to minus the area of the triangle. The area of the circle is pi r squared, and the area of the triangle is really base times height divided by 2. Okay, so in this problem, the radius is r, so the area of the circle is just pi r squared minus, now take a look at the triangle here. This is your base, and this is your height. The height is also r, right? So base times height is just r times r, and then divide by 2. Okay, so this will be pi r squared minus r squared divided by 2. And then from here, I can factor out the r squared, right? So both terms have an r squared, so pull it out by factoring it out. And what's left? Pi minus, well, there's an invisible 1 here, and there's a 2 on the bottom, so it'll be pi minus 1/2. And that's your final answer. And just remember, if you distribute this through, I mean, you do get pi r squared minus, 1/2 r squared, which is basically the same thing as that line right there, right? So this answer right here in the red box is your final answer. Okay, let's move on to letter B. Find the area of the shader region in factored form. Okay, so this whole length here is x, and this whole length is x. So this is the area of the big square minus the area of the little square here, where this is x times x, and this is going to be y times y, right? So base times height, or sorry, length times width. So length times width is x squared minus length times width, which is y squared. And although this is correct so far, you need to factor this because this is a difference. You can use the difference of squares factoring technique on this one. So I need a plus sign and a minus sign. Square root that, I get x plus y and x minus y, and that's my final answer for that one. Okay, let's move on to letter C. Okay, for letter C, you need to recognize that this distance right here in red is a radius. That means this blue distance right here is a radius. This blue distance here is a radius, and this red distance right here is also a radius. Therefore, if I take a look at this entire purple length here, it's going to be r plus r plus r plus r, so that's going to be 4r. Okay. You also need to recognize that this red distance right here is r, and this blue distance down here is also r. So this entire purple distance here is going to be 2r. Okay. All right, so if you want to find the area of the shader region, which is essentially this blue stuff right here, and I hope that's a little bit more clear in your workbooks, your goal is to find the area of that shader region. What you're really doing is you're finding the area of the rectangle minus the area of, well, if you look at this very carefully, how many circles are there? So this blue part and that blue part, that's one full circle. And then you have the circle in the middle, so that's 2 circles, right? So really the area of the 2 circles. All right, so really there's 2 circles together. So if you find the area of the rectangle minus the area of the 2 circles, then you have the area of the shader region. All right, so this length is going to be 4r. And this width is going to be 2r. And we know the radius of one circle is r. Okay, so to find the area of the rectangle, it's going to be length times width. 4r times 2r is 8r squared minus, well, you have 2 circles, so let's put a 2 there. And the formula for the area of a circle is pi r squared. All right, so there's your expression for the shader region, and you'll recognize that both of these problems have a common factor of 2, and both of them also have an r squared, so the greatest common factor is 2r squared. Now if I factor that out, you're just dividing this by 2r squared, and you're dividing that by 2r squared. So you get 4 minus pi as your final answer there. Okay, let's move on to letter D. I think letter D is a little bit easier because you have the length and the width here. So if I want to find the area of that bigger square, it's going to be 2x plus 1 times 2x plus 1. which is going to be 2x plus 1 times 2x plus 1, which is the same thing as 2x plus 1 all squared. And then you're going to minus that smaller square, which is in the middle, which is just x times x. And x times x is going to be x squared. Okay, so there is your expression for the shader region, but now you need to factor this. Now remember, there's two terms, 1, 2, and there's also a minus sign in the middle. So this is the difference squares factoring technique, where you have a minus sign in the middle, where you have a plus and minus sign in the middle there. Then all you're doing now is you're just taking the square root of each term. So square root of that and square root of that. Well, that's going to be 2x plus 1. Actually, that's a very thick marker there. Let me get a different color here. This is going to be 2x plus 1, 2x plus 1, and the square root of x squared is just x and x. And although this is correct, you can probably do a little bit more work here. I have a 2x and an x, so 2x plus x is going to be 3x, so 3x plus 1, and 2x minus x is going to be a single x plus 1. So there is your final answer for that one there. Okay, two more of these shader region problems, and then we're all done. For letter E, if you do enough of these, you'll recognize that for letter E, all you're really doing is you're taking the area of the big circle. Let's pretend this big circle is completely filled. So that area is pi big R squared. And then you're just going to minus the area of the smaller circle, which is this blue region there, which is the area for that is going to be pi little r squared. And if you subtract those two areas, you just get this shader region in between them, right? All right, so it's pi times big R squared minus pi times little r squared. Now, since you have two terms and a minus sign in the middle, you can have two sets of brackets, a plus sign and a minus sign in the middle, and after that, actually no, let's not do that yet. I recognize that there's a pi here and a pi here, so let's go ahead and factor out the pi's. If I factor out the pi's, I get big R squared minus little r squared. And then we can factor this inside binomial, because we can use a difference of squares technique. And remember, all difference of squares technique, there's a plus sign and a minus sign, so big R plus little r and big R minus little r. And that is your final answer for that letter. Okay, final letter F here to finish off this homework video guide for part 1. Once again, the classic problem is the area of the big square, which is just x times x, so that's x squared, minus this little square. Now, in order to find that purple distance, I know this blue distance here is y, and that blue distance there is y. Okay, so if you think about this carefully, if you take all of red here, and if you take away this y and that y, you should get purple. Okay, so let me repeat that one more time. If you take all of this red length here, and if you take away this y here and that y there, you're left with this purple distance. Okay, so that purple distance is really the x minus the two y's. So that purple length equals to x minus the two y's. Okay, so what does that really mean? What we're trying to say is this length right here in purple is really x minus 2y. And that means this blue distance right here is also going to be x minus 2y. All right, because a square has the length and the width of a square are the same. All right, so I need to subtract x minus 2y, this is the length, times another x minus 2y, which is the width. So this is going to be x squared minus x minus 2y all to the power 2. All right, so that was that took a little bit of work to set it up, but you need to recognize that this is also now a difference of squares factoring problem because you have one term here and two terms there. So two terms in total, and you have a minus sign in the middle. So if you factor this, there's a plus sign and a minus sign, and after that you take the square root of both sides. So this will be x, and this will be bracket x minus 2y. This will be x, and this will be bracket x minus 2y. Now x plus x is going to be 2x, so 2x minus 2y. And if I distribute the minus sign here, that's going to be negative x, and that's going to be plus 2y. Actually, that really didn't come out very nicely there. So if I distribute that, that's going to be negative x, and this minus sign goes over there, I get plus 2y. And you'll notice that this x and that x, they cancel each other off, and you're just left with the 2y over here. Okay, that's good so far. One more thing you can do is there's a 2 and a 2 there, so if you want to factor that out, you can. And one more thing you can do is there's a 2 here and a 2 here, so 2 times 2 is going to be 4, so 4y and x minus 2y. All right, so that's it for the factoring problems on section 2.6.